So now we're going to be looking at Euler's method and the logistic equation. So the first few problems are going to be Euler's method. And the whole point of Euler's method is to estimate a solution to a differential equation. Because maybe you don't have any techniques to directly solve the exact solution, so we're going to try to estimate it. And so when you start with a differential equation like this, I have dy dx is equal to x plus 2y. What you want to think is really that the dy is delta y. You approximate this as saying, well, the change in y divided by the change in x is equal to x plus 2y. And so my change in y is equal to x plus 2y times delta x by multiplying my dx there. Okay, and so we're going to start at an initial point typically. In this case, we're going to start at x equals 0, y equals 1. And then you're going to make these columns, delta x and delta y. And you're going to compute each of these. Now, delta x is typically fixed. We're going to go 0.25 for this case. And what you're going to think about is, what you're going to say is, given these parameters, what is my change in my y value? So my change in my y value at this point would be x plus 2y all quantity times delta x. So that would be 0 plus 2. So in this case, it would be quantity 0 plus 2 times delta x, which is 0.25 in this case, and that is 0.5, right? 2 times 1/4. So now we know what our delta x, delta y is. The next step is to say, okay, we're going to move over a delta x to go 0.25, and my y I'm going to change by delta y, 1.5. My delta x is always fixed typically when we're doing Euler's method. That's what h is. And we're going to say, okay, now we're going to do delta y again. This is 0.25, x plus 2y, plus 2 times 1.5 is 3, times delta x, which is 0.25. And that equals 3.25 times 0.25. I can use a calculator for this. 3.25 times 0.25, and I get 0.8125. Okay. Delta x, we're going to add again, 0.25 to get to the next x value is 0.5. My y is going to go 1.5 plus 0.8125, because this is my delta y, it's my change in y. This is a 2.3125. Delta x is still 0.25. And then we're going to say, to find delta y, it's 0.5, x plus 2 times y. 2 times this is 4.625. And my delta x is still 0.25. And using my calculator, I get 1.28125. Okay, sorry, it's blocking out a little bit there. And then we're going to add delta x to x, 0.75. We're going to add this to y. So I'm going to add 2.3125. I'm going to get 3.59375. My delta x is still 0.25, and then this is going to be 0.75. X plus 2 times y. It's 7.1875 times 0.25. And then we get plus 0.75 times 0.25. 1.984375, kind of a log number. And now we do it one more time. We get 1.0, add this to y, 3.59375, add my delta y, 5.578125. And that's my answer because they wanted us to find, use the table up to x equals 1. And so this would be my y value. This would be the approximate solution to the differential equation at 1. Okay. Here's another one here. We're going to do dy dx is equal to x e to the y. And if you're okay with this, we don't have to make them deltas. Some people like to use it as deltas. I sometimes do that because conceptually it might be easier to think of delta y's and delta x's. But we're going to do the same thing here. We're going to go in interval 0 to 0.5, and we're going to do it in 5 sub-intervals. So the way you want to think about it when we're doing 5 sub-steps, we're starting off with our x and our y. our x's start to 0, 1. And we want to go to 0.5, but we divide by, we want to do it in 5 steps. So that's going to be 0.1, 0.2, 0.3, 0.4, 0.5. So you can see my dx is always going to be 0.1. And now we need to calculate dy for each of these scenarios. Well, my dy is x e to the y dx. So it's going to be 0 times e to the y times dx. It's still going to be, it's just going to be 0. Because x is 0, my it doesn't matter what the rest of this. E to the y, e to the 1 times 0.1 is still going to be 0 there. So my dy is 1, so 0, so then the y is going to stay at 1. My x and dx are still the same. My dy, now for the next step, x is 0.1, so it's going to be 0.1 times e to the 1 times 0.1, because that's my dx. So we're going to do 0.1 e to the 1, 0.1, and I get 0.02718. Okay, and so we're going to add that to y, so now I'm going to be 1.02718. Now we're going to do this one again. This is x, 0.2, e to the 1.02718 times my dx. And then I gotta change this to 0.2. So 0.056. We'll just go 3 decimal places, keep it a little simpler. So I'm gonna add 0.56 to this 1.02718, and I get 1.083. My dx is always the same. My dy, this is gonna be x is 0.3. E to the y, which is 1.083, and my dx is 0.1. So I'm going to do 0.3 e to the 1.083 times 0.1. My calculator, I get 0.089. So I'm going to add that to my y value. So I'm going to go plus 1.083. I get 1.172, 0.1. This is going to be, find my dy again using this equation, 0.4 e to the 1.172 times 0.1. And I get 0.129. And then finally, the y value, we just add it to here, 1.301. That completes, that would be what the value is at that point. Now, the problem is that you're always introducing a little bit of error, so the further you go out, when you do Euler's method, the larger the error is going to be, because we're not doing an exact calculation. Smaller step intervals would give you a more exact answer, but these are only approximation. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.